Good morning, good afternoon, and welcome to our conversation today for a report on RAN optimization that Sensa Feely has written in collaboration with RCR Wireless News. Today I have with me Said Mokbel from Telus, and he is the VP of Wireless Technology Development there. Said, thanks for being with us today.
Good morning, Monica.
And to get started, can you tell us what is your role? What is it you're working on at Telus these days?
Lots we're working on, but my role is mainly around the wireless technology development, as you mentioned. I'm ultimately responsible for the wireless investment direction and making, decisions that would ultimately maximize the use of the assets or optimize the use of the assets. And it goes from radio to, to the traditional core network, to the device side and beyond.
Yeah, and the resource utilization is becoming quite important because there is always more demand for data than we have resources in general. So the need to optimize, it's growing with the increase in traffic. In terms of sort of the high-level trends, how do you see the RAN optimization has changed over the last few years and will change over the next, say, 5-10 years?
Good question. I think we've moved quite rapidly from a traditional voice world where the service and the network are one and the same to a very different world of data, whereby the content is not necessarily something controlled by the operator, and in many cases a multiple path within the path itself. And so the concept of the optimization becomes a little bit more difficult, a little bit more complex, as you have to not just look at your side of the network elements, but also beyond what's happening in the flow itself. Where do I see it? I think it's quite critical that we continue to squeeze more out of the network assets. But I think we also need to start looking at step functions in the form of technologies that would ultimately solve the data hunger. I think when you look at LTE, where we are now, and the LTE advanced set of capabilities, that will continue to give us incremental benefits. But I think we are now entering a world, whether it is the amount of connections we're going to have in a hyper-connected world, or the appetite for a lot more consumption, we will need to be looking at different ways of serving the end user, whether it's a machine or a human or what have you. I don't think it's a secret where the world is going from connecting everything, not just humans, but beyond. And I think this is where we will see a lot of effort to try to figure out what is the best way and the most optimal way to deal with the connection of the machines, the IoT world, that we speak of quite a bit in recent weeks and months. And I think we have focused traditionally on broadband and trying to squeeze more and have wider channels and all that, but I don't think we have paid attention as much to the amount of connections that we need to serve, that many of which could be narrowband, many of which could be stationary or semi-stationary, many of which that do not need to transmit in a uniform fashion, in a two-way, duplex fashion. I think that is a world that we have not paid as much attention to because the revenues weren't necessarily coming from there. But as we progress in growing our capabilities and generating additional revenues, it is a segment that would require quite a bit of work on the technology side, but of course on the business acquisition side of things as well.
Yeah, and as you say, this is something that is quite interesting with IoT. It's that it's not just more traffic. It's more connections and the different types of traffic. So in order to optimize what used to work before in a voice-only world is no longer works, not only because it's data, but because it's different types of data. And so how can you optimize different types of data traffic or optimize, be able to support a higher number of connections within the same network?
It's a good question, and you said it right. I think if we look at the progression of the IMT set of technologies, 4G and LTE was truthfully the first time we had an optimized technology that is IP based, and it's working well, and it will continue to work well for a variety of use cases. I think in the case of IoT, we are probably going to have to look at different ways of addressing IoT traffic. And even within IoT, it's a catch-all phrase, right? It's Internet of Things. What are those things? What are they trying to do? They're not going to be all similar. But certainly, we know that we can have a better narrowband air interface than what we have today in LTE, specifically for IoT. And there are things we can do within the technology standards around non-orthogonality, which is, we've used that very well with OFDM for broadband, but perhaps for some narrowband aspects, we can tweak the technology further to be better positioned, better optimized for IoT. And we're seeing, standards for IoT or activities around IoT coming from within multiple standards bodies that are trying to solve that, both from the licensed world as long as the unlicensed world. So the jury is still out, but it is definitely an area that, here is the beauty of emerging and nascent markets. There is a lot of innovation, there is a lot of competition, and with that usually comes fragmentation. I think we need to ensure to the maximum extent possible that we have some kind of not consensus, but alignment on how we could best serve an IoT segment with its multiple flavors, and not get into a disarray of a dozen of technologies trying to address the same space, because we know ecosystems will never develop to its maturity in the time frame we need it to. So we see those debates happening now, but hopefully in the next 12 to 18 months, we can get a bit more clarity on where we're going, and hopefully alignment.
Yeah. Now, another source of additional complexity comes from the deployment of small cells. So you have multi-layered networks, and you have to manage them. How is that changing the way you optimize your networks?
Small cells is an interesting space in its own right. We've been talking about small cells for a very long time. I don't think we have really done, as an industry, as much on small cells as we would like to. Let me just say, maybe I'm going on a sideways, on something. Small cells, at the end of the day, and when we talk about the hyper-connected world that we see in 5G, where there is a modem and everything, and there is a small cell or a tiny cell or whatever you want to call it, and just about everywhere. That is the world of small cells that we anticipate and we expect to see. For small cell, how do you optimize them and how do you deploy them is a question of how do I put it? It's not as simple as what we've done traditionally with macro networks. We know how to build macro networks, the industry at large. Small cells, it's a bit of you have to know what you're doing. Unlike in a macro cell where, if I can't acquire this particular building to put my macro cell, I can move, 100 meters, 200 meters, put another macro cell, in that building. With small cell, you have to be more particular because the coverage is limited. However, when we get into a hyper-connected network in the future, the placement of these small cells will not become an RF engineering exercise anymore.
Mm-hmm.
You're not going to engineer it. You're just going to have to plug it, put it somewhere. It's going to be everywhere, and it's got to connect. It's got to discover who it is, what it is, and connect back to that network. We are big fans of small cells. We've been for years, experimenting with them and deploying them. The optimization of small cells is a bit of a good RF engineering, but I think a lot of automation. Mm-hmm. You cannot, in a world of multi-band, multi-layers, so you got, macro, micro, pico, femto, and even a smaller form factor, operating in a variety of bands and multiple bands for some of them. You cannot data fill all of this, and the traditional RF engineers would do. I think we need to get into automation, and this is where SON, self-organizing networks, come in a big way, because the processes involved here in optimizing and maximizing the user experience are too granular, too complex, too fast for human to predetermine in a dynamic, in a static form, in the form of, data filling the information in advance. So SON is at the center of managing and optimizing the HETNet network, and it will only become more critical as time goes by, because frankly, for the point I was making earlier, small cells have not taken to the same level that people expected or we would have liked. We've been, like I said, we've been a big proponent of it. And there are reasons why they haven't happened as fast as they should. But when we start getting into the world that we envision, around the 5G timeframe, which is hyper-connected and where cells are everywhere, you cannot, optimize that by defining rules statically in the system and expect all of that to happen. This is where you need an automated type environment, where SON will be a critical component of that optimization.
Now, within SON, what are the features that have been so far deployed more successful, that have been more useful, and the ones that we're still having a little bit of a challenge, but are going to be more promising in the sort of longer term?
So the promises of SON, we have barely scratched the surface, if you ask me. I think what we've seen mostly with SON is, and SON is not as, like if you go around the world, you'll see more SON deployments in certain places than other places, and it all depends on the environment. We see things like plug and play features, whereby you just turn on the base station and it downloads the software, connects to the network, and automatic neighbor list, discover who its neighbors is, and that. We see those features, which are very basic, very labor intensive. We see those deployed. When you look around, you see that. But the ones that are really will become critical to run this network are just emerging. Things like load balancing. Load balancing across cells in the same cluster, potentially across bands. Things like detecting the thresholds for handovers and optimizing the experience to minimize drop calls. Things like centralizing having a centralized SON server to actually gather data from all the cells and optimize network according to certain predefined policies and rules. Those things are just emerging. And those will become very critical with small cells. The macro network, we all have done it. We know what to do. We're not growing macro in large numbers. The number of sites are understood. You can predetermine and pre-populate all your data fill there. But once you start throwing small cells, and I did say even as an engineer. The small cell cannot be engineered down the road. It has to go in a place where you think, hey, I think I have traffic here. Doesn't have to be accurate, because there will be another cell not too far away from it, and so on and so forth. That is a world where optimization will have to become very dynamic. And this is where centralized SON and some of the other SON features become critical. And I must add here, in this world of multi-layer, multi-band, you could see multi-vendors, right? We don't all have a single vendor in a particular market. And, with all the interfaces opening up, you could be mixing and matching vendors. We haven't talked about the Cloud RAN, for instance, and having the openness between the baseband and the radio. You can have radio from multiple vendors. The key is this self-organizing network capability have to be able to interface with the various radio vendors and have to be able to interwork right across. Otherwise, we all know it works best when it all comes from the same vendor.
Mm-hmm. Right.
Optimized for that vendor. But the world we're going into is going to be a multi-vendor, very rich. And SON to date has not been very open, as continues to be. I mean, we hear talk about it becoming open, but we continue to see vendor-specific SON capabilities and interfaces.
Yeah. Now, you mentioned load balancing across interfaces, but you can also do load balancing and manage traffic at the application level rather than at the overall level. And typically, when you do the managing of traffic at the application level, tends to be more in the core. Do you see that being pushed more towards the edge in terms of prioritizing traffic depending on what the traffic is about?
Yeah, so I know I've been talking about the radio most of the time here, but absolutely we do deploy optimization techniques also at the application layer today. They do a very good job for the purposes that we're created for. Call it compression, call it throttling, call it mediation, right? However, for me, without upsetting any particular vendor in any space, the more optimization you do in real time at the cell edge, the better off you can be. Not always, but you can be, because if you optimize right at the source, your life will be easier at the application layer. It doesn't mean that you're done at the source and the radio. The application layer is still very important to optimize. However, you asked a question. As we move into the future, do you see more optimization happening closer to the edge, closer to the radio side? I say yes. I mean, if we look at some of the latency requirements defined by the 5G world and where 5G can go and should go, we see some very strict latency requirements. The 1 millisecond, you probably heard the the round trip 1 millisecond being a critical one between the content, between the serving function and the radio. If you look at that, it's basically talking about seeing more capabilities, whether they are processing capabilities, whether they are higher layer capabilities, whether they are related to content and application, getting closer and closer and closer to the edge. So I would envision a world where a lot of the things we do today or we see today being done in the core network away from the RAN, getting pushed further down into the RAN and having those capabilities built right inside the RAN. Without any doubt, I think we're moving into a world where we're going to see more and more and more stuff being pushed to the edge to meet a lot of the requirements we see in the future. It doesn't mean that everything has to be pushed to the edge. I mean, like voice today is fine the way it is. It doesn't have to be, pushed right to the edge. But there's a lot of real-time, sensitive, high latency application and use cases that go with them that many bodies are trying to define, the NGMN being a big one in that space, which would force us to design things very differently and get closer to the edge.
Now, is that the sort of like the move towards CRAN, is it going to also play into this? Because once you have remote processing in a CRAN, with a CRAN, it also might help moving a lot of the processing to the edge in terms of like caching and things like that. You think that the two are sort of converging, or are they two different parallel developments?
I think CRAN in itself, I don't think they're necessarily related. Mm-hmm. I think CRAN is about getting the most out of your network in a, heavy traffic locations, optimize the experience, optimize your cost, get more out of your system, and therefore, for the audience, you're going to have a baseband, call processing pool that could be directed wherever there is traffic in the network. Those resources do not have to be any more tied into a particular radio, but they could be directed wherever that radio or radios are busy. So that's a smart thing to do. Of course, with CRAN, we also get better coordination at the edge for a better experience. So it's not just about better cost optimization, but also about the user experience being better optimized. I think beyond that, we get into a world where you will have a radio anywhere and everywhere, and that's not necessarily CRAN, and that's not necessarily, it's not necessarily smart to separate the baseband from the radio. When I have a very tiny radio that I've just plugged against the wall, to me, it's probably, it's an end-to-end, it's got all the functions in it. That's the world we aspire to see. I think part of the reason, we started talking about small cells, we haven't seen small cell explode to the level we wanted to see it explode to, and the level we need it to, is because of the cost. And it's not the cost of the radio. Not that the radio needs to continue to get cheaper and more efficient, but the cost that is associated with the real estate, the civils work, and especially backhaul. Mm-hmm. And as long as, and I have been, for maybe a good 5, 6, 7 years now, every time I meet with a vendor, I say, when am I going to see this small cell? And we've been talking about small cells to all our vendors and other vendors for a very long time, believe me. We start getting some of what we want very late because the ecosystem had to develop. And there is a history why we were very big on small cell, which I would say for now. But my question was always, when do I get to see the small cell backhaul itself? Because we've done experiments. We've seen the cost of deploying small cells outside the radio cost. Mm-hmm. And this is where the money is. This is where the money goes. And every time I would ask this question, they'd look at me funny. Why? I said, until it backhauls itself. Mm-hmm. What do I do with it? It's very encouraging now to hear, when you look at some of the 5G work items around full duplex and self-interference cancellation becoming very, very much talked about now, and potentially can solve the small cell backhaul conundrum. Because I believe until that is solved, we're not going to see small cell deployed in any meaningful way.
Yeah.
Cost-wise, you can.
Yeah, that's a major challenge. It's sort of beyond the sort of the real the small the fine grain optimization. You need to make sure that you're able to deploy in a cost-effective way. Now, before I let you go, I wanted to ask you a final question on mobile edge computing, because as we were talking about before, everything is sort of moving a little bit towards the edge. Do you think that there is much potential there?
I think there is quite a bit of not only potential, but a need. And I think there is a lot of activities out there today around mobile edge computing. I think when we look at the applications and the use cases that we envision coming to the surface in the coming years. And there's a number of bodies that are talking about the 5G use case. I'm the most familiar with the NGMN. We're a member, and we're quite active there. You look at some of these use cases, and you say, well, how am I going to solve that? I mean, we mentioned the latency requirement earlier on. It can only be solved with mobile edge computing. So it's not a technology for once. And this is why I'm heartened by 5G, and I know this the topic today is not 5G, but I'm heartened by finally a technology driven by business models and use cases, and not the other way around. All right, and we look at many of the use cases, and we say that the only way you're going to be able to solve them is to do something very different architecture-wise than what 4G or 3G or 2G were. And 5G will look extremely different in the sense that not only it will embrace a lot of, existing technologies like 4G, but it also and federate and intermediate various types of potentially air interfaces to fulfill the end user experience. But mobile edge computing will be at the heart of it, and it is it's an enabler and a problem solver for some of the 5G use cases and the 5G requirements. So absolutely, and I believe the next few years on the road to 5G, we will see quite a bit of activities in mobile edge computing leading up to having a mature technologies before 5G arrives on the scene.
Yeah. Well, thank you very much. And 5G is going to be, next time we'll talk about 5G. Said, thank you so much for sharing your thoughts with us today. Thank you, Monica. And we had a conversation today with Said Mokbel at Telus, and this is part of a report on RAN optimization that Sensafili has written in collaboration with RCR Wireless News, and that it's available to download from the RCR Wireless News and Sensafili website. Thank you very much for attending.